So one of the important issues in ecology is how we want to address the complexity and uncertainty in ecology. Important questions in ecology are more than a matter of biology. For instance, can they affect our well-being, or can they have an ethical component? An example is species diversity on a tropical reef. This diversity poses one of the central questions in biology. Why are there so many species in such a small area? Okay, and what causes such diversity? Is there any correlation between the reef and the fish species? Any physiology? Is the nutrient, how the nutrient affect the diversity of the species? We need, okay, there's a lot of questions. Of course, this variety of species might affect the well-being of island people who fish the water for food from the reef. So their lives and culture are adjusted to the peculiarities of the species found on the reef. So plus the well-being of island people who make a living from tourism, okay, depends on the continued diversity of the reef. So of course people will would like to come, the outsiders want to come to look at the reef because of the beauty, because of the diversity. So you want to maintain the diversity, and how to maintain that kind of the diversity, how we can prove such a relationship. So for instance, the nutrient, how is there any effect of the tourism towards the diversity of the reef? Of course, at a larger scale, the well-being of the local people can be improved by the discovery of special therapeutics or medicine from the reef. So probably a special reef, I don't know, right? A special species in from the reef is has a very good therapeutic that can improve the well-being of the people. So the diversity of species on the coral reef also raises ethical issues. Okay, reef inhabitants, tourists, and the beneficiaries of new therapeutics can be lost if diversity is eroded by destructive practices such as overtourism. How to juggle this complex decision? No tourism, economy of local people can drop. Increase the number of tourists? No, definitely. We need to compensate with ecological and environmental impact. So, the biggest question here, how do we address ecological problems characterized by this complexity and uncertainty? We don't know if we do something, can it change the coral reef population? If we do some uh, alteration, can it improve, or can it destroy the reef, or can it improve the reef? For instance, if you put uh, things for like a fake coral reef, can increase the diversity. How we can make an informed decision, okay, based on the data that we have. So we may have the numbers, but how we can translate them? So of course we have no choice but to use a model to simplify and make sense of the situation. So how we want to create a model? Again, for this course, I'm not going to discuss the development of a model, but rather I want to just give a brief concept on how certain model was developed based based on verbal, graphical, and formal statement. So in biology, the classic solution to the to the problem of complexity is a verbal or graphical model obtained by the comparative method. Okay, the first step toward a quantitative model is a verbal. What is a verbal? This is a statement of the relation among measurable variables. An example, okay, uh, that example of a statement, a verbal statement is that the release of nutrients into a lagoon will alter coral abundance. That is a statement. So a verbal statement. so a hypothesis, if I can say. A verbal model can address both causality and uncertainty. The effect of nutrients on coral in a lagoon may occur with considerable local variation. So the nutrients is a variable that can change. We can increase the nutrient, we can reduce the nutrient. So the verbal model is the door to a graphical model. Okay, it's a door to a graphical model in which data are simplified to a graphical model. Like this, we can plot the data as a graph. Okay, for example, from the data collected in previous experiment or previous survey, we could sketch the expected form of the relation of coral growth to nutrient release. Okay, uh, so where it showed that high nutrient levels slow the growth of coral. Then the data can be simplified to a formal model, which is an equation describing growth in relation to uh, the nutrient levels. Based on this preliminary model, we can make our own experiment in the lab, where we could be used as preliminary model to predict effects in the lagoon. Okay, the number of samples needed to detect the predicted effect could be computed from a model of uncertainty, such as a normal error distribution. Okay, so for instance, this model can be used in any kind of situation. So from the words to graph to equation, kind of like sequence. Again, like this one, this is the example I gave here. I gave in my lecture is it's in terms of coral reef, but here in this figure is the relationship of species number to an area. So it can be anything. Okay, so because this figure represent an effective approach to any ecological problem, which is to begin with a question, and then sketch the suspected relationship of the key variables, and then graph it of these variables, then estimate the formal relation as a function. Okay, as shown here. So you can, for instance, like I say, this is the what is the relationship of the number of based on the number of arrays. You can see based on array, then you can see when you get the graph here, and then you plot it, and then you get the number of species is equal of this k divided by area beta here. So there is an equation based on the graphical uh, situation of graphical statement here. Of course, this is not straightforward. The sequence from verbal through graphical to formal expression of a model usually is not as straightforward as it looks. You need to proceed by iteration rather than as a simple progression. So a verbal model formulated as a question will be compared to data, leading to a revised question and a new model. So most of the time you need to process the data many times to get the right formal equation. So that's why I don't want to give. So how to develop this model is you need to have a very strong mathematical and statistical knowledge or understanding or experience, if I can say. But again, this iteration cycle of challenging model against data continues until an acceptable model emerges.